Let's dive into the fascinating world of steam locomotives by first understanding the basic mechanics and engineering principles behind these powerful giants. Steam locomotives are, in essence, a marvel of engineering that harnessed the power of steam to propel the engine and move across the rails. To comprehend how steam locomotives work, it's essential to know how steam is generated and used. The process starts with a firebox, where coal or wood is burned to produce heat. This heat is then used to boil water in the boiler, which creates steam. The steam, being under high pressure, is then directed to cylinders containing pistons. The steam's expansion inside the cylinders pushes the pistons, which are connected to the locomotive's wheels, through a series of rods and cranks. As the pistons move back and forth, they turn the wheels, propelling the locomotive forward or backward. Once the steam has done its job in the cylinders, it's exhausted through a smokestack, which also helps create a draft that draws fresh air into the firebox, fueling combustion. Now, let's talk about the various components of a steam locomotive. There are several key parts, including the boiler, firebox, cylinders, pistons, wheels, and the cab where the engineer operates the engine. Additional components such as the tender, which carries extra fuel and water, and the smokestack, which releases exhaust steam, are also crucial to the locomotive's operation. In summary, steam locomotives are a testament to the ingenuity of early engineers who were able to harness the power of steam to revolutionize transportation. With their intricate systems of boilers, fireboxes, and cylinders, these powerful machines were able to reshape the landscape of rail travel and contribute significantly to the Industrial Revolution. Now that we have a grasp on the basic mechanics of steam locomotives, let's delve into their fascinating history and development. The story of steam locomotives begins in the early 19th century, when engineers were experimenting with steam-powered transportation to replace horse-drawn carriages. The first steam locomotive was built by George Stephenson, an English engineer, in 1814. It was called the Blucher and was used to haul coal at a colliery in England. However, it was Stephenson's next invention, the locomotion, and one that truly marked the beginning of rail transportation. In 1825, this locomotive pulled the first ever passenger train on the Stockton and Darlington Railway. Throughout the 19th century, steam locomotives continued to evolve as engineers made significant advancements in their design and efficiency. For instance, in 1830, a rocket, also designed by George Stephenson, won the famous Rainhill Trials, a competition held to identify the best locomotive for the Liverpool and Manchester Railway. The rocket's innovative design, which featured a multi-tube boiler for improved heat transfer, set the standard for future locomotives. During the mid-19th century, steam locomotives played a crucial role in the expansion of rail networks across the world. They became the driving force behind the Industrial Revolution, enabling the fast and efficient transportation of goods and people. Countries like the United States, Germany, and Russia developed their own locomotive designs and manufacturing industries, creating a competitive environment that pushed technological advancements even further. By the early 20th century, steam locomotives reached their peak in terms of power, size, and efficiency. But some of the most famous locomotives from this period include the Union Pacific's Big Boy, which was the largest and most powerful steam locomotive ever built, and the Flying Scotsman, known for its record-breaking speed and stunning design. In conclusion, the development of steam locomotives from their invention in the early 19th century to their peak in the mid-20th century was marked by remarkable advancements, milestones, and influence. These powerful machines revolutionized transportation and played a vital role in shaping the world as we know it today. Moving on to the next topic, let's examine the significant roles steam locomotives played in shaping the economy, society, and infrastructure of countries across the world. As the backbone of early rail transportation, steam locomotives were instrumental in the expansion of rail networks and the Industrial Revolution. First and foremost, steam locomotives transformed the economy by providing a fast and efficient means of transporting goods, raw materials, and people. This allowed industries to expand rapidly as they could now access resources from far-flung locations and distribute their products to a wider market. Consequently, international trade flourished, and the overall standard of living improved as goods became more accessible and affordable. In addition to economic benefits, steam locomotives also had a profound impact on society. The ease of travel afforded by rail transportation led to increased mobility, allowing people to move away from their hometowns in search of better opportunities. This triggered a wave of urbanization as cities grew and people flocked to industrial centers for work. Social mobility increased as people from different walks of life started interacting more frequently, and a new, more interconnected world began to take shape. The expansion of rail networks driven by steam locomotives also had a lasting effect on the infrastructure of countries worldwide. Railways connected distant cities, towns, and rural areas, which in turn spurred the development of new roads, bridges, and tunnels. This improved infrastructure facilitated further economic growth as businesses gained easier access to both resources and markets. In relation to the Industrial Revolution, steam locomotives were a key driving force. The ability to transport large quantities of goods and raw materials over long distances changed the way industries functioned. Factories and mills could now be built near sources of raw materials, such as coal mines or iron ore deposits, and then use rail transportation to distribute their products efficiently. This led to a dramatic increase in production, fueling economic growth and technological innovation. In conclusion, steam locomotives played a pivotal role in shaping the world we know today. By revolutionizing transportation and facilitating the expansion of rail networks, they transformed the economy, society, and infrastructure of countries worldwide. Their influence on the Industrial Revolution and the subsequent growth of urban centers has left a lasting impact on our modern landscape. Now that we've discussed the broader impact of steam locomotives on the world, let's focus on the various types and classifications of these magnificent machines. Steam locomotives can be broadly categorized into three main types: tank engines, tender engines, and articulated locomotives. Each type has its specific uses and regional variations. First, let's talk about tank engines. These locomotives carry their fuel and water in tanks mounted on the locomotive's frame rather than in a separate tender. Tank engines are usually smaller and more maneuverable, making them ideal for local passenger services, shunting operations, and working on branch lines with tight curves and steep grades. There are several subtypes of tank engines, such as saddle tanks, side tanks, and pannier tanks, each with its unique arrangement of water and fuel storage. Next, we have tender engines. These locomotives are coupled to a separate tender car that carries their fuel and water supply. Tender engines are typically larger and more powerful than tank engines, making them well suited for long-distance freight and passenger services. They can haul heavier loads and travel longer distances without needing to refuel or replenish their water supply. Some of the most famous steam locomotives, like the Flying Scotsman and the Big Boy, are tender engines. Lastly, let's explore articulated locomotives. These unique engines consist of two or more engine units connected by a flexible joint, allowing them to navigate sharp curves and uneven track more easily. Articulated locomotives are particularly useful in mountainous regions and on railways with tight curves. One of the most well-known articulated designs is the mallet locomotive, which features a compound steam system that reuses steam from the rear engine unit in the front engine unit, increasing efficiency. It's worth noting that regional variations often exist within these categories, as different countries and railway companies developed their own specific locomotive designs to suit local needs and conditions. For instance, the United States favored large, powerful locomotives for their vast rail network, while European countries often employed smaller, more agile engines to navigate their more complex rail systems. In conclusion, understanding the various types and classifications of steam locomotives, such as tank engines, tender engines, and articulated locomotives, helps us appreciate the diverse range of designs and engineering solutions employed. These unique machines were tailored to suit specific needs and regional conditions, showcasing the versatility and adaptability of steam locomotive technology. As we reach the final topic of our journey through the world of steam locomotives, let's discuss their decline and eventual replacement by diesel and electric alternatives. Although steam locomotives were the backbone of early rail transportation, several factors contributed to their decline, including efficiency, environmental impact, and changing technology. Firstly, let's consider efficiency. Steam locomotives require a lot of maintenance, from cleaning and lubricating moving parts to managing the boiler and firebox. They also consume large amounts of fuel and water, which they needed to replenish frequently. In contrast, diesel and electric locomotives are much more efficient, requiring less maintenance and consuming less fuel. They can also accelerate and decelerate more quickly, making them better suited for modern transportation needs. The environmental impact of steam locomotives also played a role in their decline. Burning coal or wood generates significant air pollution, contributing to smog and other environmental issues. As concerns about air quality and climate change grew, the shift towards cleaner forms of transportation became a priority. Diesel and electric locomotives, while not entirely emission-free, produce far fewer pollutants than their steam-powered counterparts. Lastly, changing technology contributed to the decline of steam locomotives. As diesel and electric engines became more advanced and reliable, they offered several advantages over steam power. For instance, diesel engines could generate more tractive effort at low speeds, making them ideal for freight services. Electric locomotives, on the other hand, offered a clean and efficient means of transport, particularly in urban areas where overhead wires or third rails could provide a continuous power supply. While steam locomotives continued to operate in some parts of the world well into the late 20th century, they have now been largely replaced by diesel and electric alternatives. However, their legacy remains. And the fascinating history of these powerful giants of rail history continues to captivate enthusiasts and casual observers alike. In conclusion, the decline of steam locomotives and their eventual replacement by diesel and electric alternatives was driven by factors such as efficiency, environmental impact, and changing technology. While these magnificent machines may no longer dominate the rails, their contribution to the development of modern transportation and the shaping of our world cannot be overstated.